Welcome to eLearning's video lectures in mathematics. Perhaps you are one of those students who have wondered, why do I have to do math? Or, what do I need math for? Only to be confronted with the answer, you have to do it, or it is compulsory. Well, there is a good reason for this, as mathematics is an essential tool in many fields, from natural sciences, engineering, and medicine, to social sciences like economics and sociology. So, what is mathematics? Mathematics deals with numbers, yes, but more fundamentally, mathematics is the study of quantity, space, structure, and change. Each of these areas arose out of practical concerns like commerce, land measurement, astronomy, etc., and is linked to broad and well-known subdivisions of mathematics. The study of quantity grew out of the need to do calculations in business. Of course, this starts with numbers and the operations on them which characterize arithmetics. The study of space has its origins in geometry. A branch of this, trigonometry, combines space and numbers as in Pythagoras' theorem. To understand and describe change is a common concern of natural and social scientists. The use of functions is a central concept in describing how one variable varies as another changes. Our need to understand the internal structure of functions, sets, and other mathematical concepts has given rise to the field of algebra with various possibilities for working with abstract concepts. Of course, these broad subdivisions are not necessarily studied in isolation. They overlap in many ways that have wide applications. Today, mathematics is used in many fields that point those who have knowledge of it to a variety of career paths. In the physical sciences, as chemists, physicists, and engineers. In the life and health sciences, as forensic scientists, biologists, and pharmacists. As social scientists in economics, education, and sociology. In the technical and information fields, computer technology, networking, and software development. In actuarial science, as statisticians, in medicine. There is even a career path in pure maths, or doing maths for its own sake. So you see, these are just some of the many possible answers to the question, why do I need to do math? The aim of each e-learning video lecture is to clarify a specific topic of the CSEC CSEC syllabus that students must master. We want to ensure that students understand the principles and formulae used in solving mathematical problems and the steps involved in getting from problem to solution. You will find that each topic provides worked examples showing these steps. And as you have no doubt heard many times, you must always show the working. The videos will cover aspects of measurement including area, perimeter, total surface area, and volume. Aspects of algebra including solving simple linear equations and simultaneous linear equations, coordinate geometry, and quadratic functions. While the videos attempt to cover these areas thoroughly, you will gain the most benefit if you are prepared to practice the principles that are outlined. Let me say it again. Practice, practice, practice. Nothing beats practice. It is the only way to maximize the benefit you will derive from these videos. Now we come to the CSEC math exam itself. What does this entail? The CSEC CSEC mathematics examination consists of 2 papers. The first paper that you will complete is paper 2. You have 2 hours and 40 minutes to complete this paper. This is a structured paper and is comprised of 2 sections. In section 1, you will be required to answer 8 compulsory structured questions which cover the topics sets, computation, consumer arithmetic, relations, functions, and graphs, algebra, statistics and probability, measurement, and geometry and trigonometry for a maximum of 90 marks. Section 2 consists of 3 questions covering the topics algebra and relations, functions, and graphs, geometry and trigonometry, and vectors and matrices. From these questions, you will be required to choose any 2 for a maximum of 30 marks. When in the exam, make sure to read through the question paper first to familiarize yourself with it and to get an idea of what you will be required to do. Choose the question with which you are most comfortable first. You do not have to answer the questions in numerical order. Before attempting any question, read over the question carefully until you are sure what it is that you are being asked to do. Pace yourself. If you find yourself spending too much time on one question, move on to another question and come back to the question later. And finally, show all working. You will not receive all possible marks if you do not show all the steps in arriving at your answer. The second paper you will complete is paper 1. This consists of 60 multiple choice questions to be completed within 1.5 hours. For each question, you will be given 4 options to choose from. The answer is there, so you must choose one. Even if you are unsure of an answer, choose one just the same. As a matter of fact, some people will say, when in doubt, choose C. Enjoy the series, and as always, practice. Many centuries ago in ancient Greece, a mathematician named Pythagoras demonstrated an interesting truth about triangles. He demonstrated that if a triangle is a right-angled triangle and you make a square on each of the 3 sides, the largest square has the exact area as the other 2 squares put together. The longest side of the right-angled triangle is the hypotenuse. So the formal definition of Pythagoras' theorem is, in any right-angled triangle, the square of the hypotenuse is equal to the sum of the squares of the other 2 sides. So in a triangle whose hypotenuse is C, the square of A plus the square of B is equal to the square of C. Let us see if this really works using an example. A right-angled triangle has sides 3 centimeters, 4 centimeters, and 5 centimeters. Let's check if the areas bear out the truth of the theorem. 5 squared equals 25, and 3 squared plus 4 squared equals 9 plus 16, which is also equal to 25. This proves that Pythagoras' theorem is true. But suppose we don't know what the length of the hypotenuse is. If the other 2 sides have lengths 5 and 12, we know we can square them and add them to get the hypotenuse squared. So, 5 squared plus 12 squared equals C squared. C squared equals 169. To find the value of C, which is the hypotenuse, we have to find the square root of 169, which is 13. We can use Pythagoras' theorem to derive the formula for the length of a straight line on a graph. Once we have this straight line, we can complete the right angle triangle by drawing in the rise and the run. The rise and the run would be the two short sides. So we can square them, and that would give us the length of the line squared. Of course, the length of the line would be found by finally finding the square root. So length squared equals rise squared plus run squared. Since the rise and the run are the difference or changes in the y and x values, respectively, length squared equals y1 minus y2 squared plus x1 minus x2 squared. So of course, to find the actual length, we then find the square root. So, if the line AB has coordinates 2, 2, and 6, 5 respectively, what would be its length? First, we assign values. x1 equals 2, x2 equals 6, y1 equals 2, and y2 equals 5. So the length of AB would be equal to the square root of 2 minus 5 squared plus 2 minus 6 squared. Which is equal to 5. Now remember, we're finding the length, so it must be measured in units. Can you find the length of the line PQ with coordinates -4, -6, and -10, -4 respectively? Be careful with the negative numbers. Let x1 be equal to -4, x2 equal -10, y1 equal -6, and y2 equal -4. So the length of PQ equals the square root of -6 minus -4 squared plus -4 minus -10 squared. Which is 6.32 units. We can also locate that point which is halfway on the line. This point is the midpoint of the line. It is a point, so it has coordinates, and it is usually denoted by the capital letter M. The midpoint refers to the middle of the line. To find that point that is halfway along the line is to find the average of the two endpoints. Let us find the midpoint of the line AB with coordinates 2, 2, and 6, 5 respectively. We average the x coordinates and we average the y coordinates. Remember that the midpoint is a point itself, so it has coordinates, and so x must come before y. Averaging the x coordinates gives us 4, and the y coordinates gives us 3.5. So the midpoint of the line AB is 4, 3.5. So then, what would be the coordinates of the midpoint of PQ with coordinates -4, -6, and -10, -4 respectively? The midpoint would be -7, -5. So now we know how to find the length of a line as well as its midpoint. Quadratic functions and applications are a large part of mathematics and our daily lives. For instance, the force of gravity can be modeled with a quadratic function. Look at the following video. What do you notice about the path of the ball? It changes direction. It was going up and then it went down so that the other boy could catch it. When the ball is thrown, the path forms what is called a parabola. A parabola is a smooth curve which represents a quadratic function. A general quadratic function has the form y equals ax squared plus bx plus c, where a, b, and c are constants, and a is not equal to 0. An example of such a function is y equals 2x squared plus 4x plus 6, where a equals 2, b equals 4, and c equals 6. Other examples of quadratic functions include y equals 3x squared plus 4x minus 6, f of x equals 3x squared minus 2x plus 5, y equals negative x squared plus 7, or simply y equals x squared. For each of these examples, can you tell what the values of a, b, and c are? In the function y equals 3x squared plus 4x minus 6, a equals 3, b equals 4, and c equals negative 6. In the function f of x equals 3x squared minus 2x plus 5, a equals 3, b equals negative 2, and c equals 5. In the function y equals negative x squared plus 7, a equals negative 1, b equals 0, and c equals 7. And finally, in the function y equals x squared, a equals 1, and both b and c are equal to 0. Note that any equation that has 2 as the highest power of x is a quadratic function, and that it is possible for b and c to be equal to 0. Let us look again at the path of the ball in the video. Notice that the path of the ball starts to move back towards the ground after it reaches a particular point. This point is called the turning point. This turning point, because it is the highest point, is called the maximum turning point. Now let us look at the graph representing the quadratic function y equals negative x squared plus 5x plus 6. To draw the graph of this function, we first obtain values for the domain x and substitute them into the equation to find corresponding values for the range y, just as we did when we were plotting linear graphs. Note that the coefficient of x squared is negative 1. Let us look at the table showing the values of the domain and range. That is, the coordinates of the points that will lie on this curve. We take these coordinates and plot them on the graph. Points should form a parabola. We then draw a smooth curve through the plotted points. Since it is a curve, we do not use a ruler, because a parabola is a smooth curve and not jointed segments. Do you see that the curve we just drew is similar to the curve formed by the path of the ball? Okay, now let us solve the equation negative x squared plus 5x plus 6 equals 0 by factorization. We multiply the first and last terms, which gives negative 6x squared. We then find two factors of negative 6x squared, which when added together give us positive 5x. These factors are 6x and negative x. We replace the middle term, positive 5x, with these two terms to give us negative x squared plus 6x minus x plus 6 equals 0. Next, we group the terms in twos and factorize each group to give x minus 6 times negative x minus 1 equals 0. So our solutions for x are 6 and negative 1. Now look at the graph and find the point where the curve crosses the x-axis at 6 and negative 1. So we see that the solutions to the quadratic equation are the same as the points where the curve of the same equation crosses the x-axis. This is where y equals 0. Remember the two little boys throwing the ball? The point where the path of the ball changed direction was the turning point. Can you find the turning point on the graph of y equals negative x squared plus 5x plus 6? If we folded the curve so that it maps onto itself, we see that a line which divides the curve into two identical parts is formed, which passes through the turning point. This is the axis of symmetry. The equation of the axis of symmetry can be obtained by reading off the x-coordinate of the line and equating. So, for the function y equals negative x squared plus 5x plus 6, x equals 5 over 2, or 2.5. The turning point of the curve is where the axis of symmetry and the curve intersect. The maximum value of this quadratic function is found by reading off the y value at this intersection. This is 12.25. Therefore, the coordinates of the turning point are 2.5, 12.25. What if the curve had a minimum turning point instead of a maximum turning point? Let us look at the graph of the function y equals x squared minus x minus 6. Just as before, we obtain values for the domain x and calculate corresponding values for the range y. Let us look at the table showing the domain and range. Now we plot the points and draw a smooth curve through them. The curve has a minimum turning point this time. What would be its axis of symmetry? X equals 1/2. The minimum value would be negative 6.25. So the coordinates of the minimum turning point are 1/2, negative 6.25. Okay, now let us solve the equation x squared minus x minus 6 equals 0 by factorization. We multiply the first and last terms, which gives negative 6x squared. We then find two factors of negative 6x squared, which when added together give us negative x. These factors are negative 3x and 2x. We replace the middle term x with these two terms to give us x squared minus 3x plus 2x minus 6 equals 0. Next, we group the terms in twos and factorize each group to give x minus 3 times x plus 2 equals 0. So our solutions for x are 3 and -2. These points are the points of intersection of the curve and the x-axis. It is important to note that when drawing graphs of quadratic functions, if the coefficient of x squared is positive, then the graph has a minimum point. And likewise, if the coefficient is negative, the graph has a maximum point. Mensuration is the part of mathematics that sets out the rules for finding lengths, areas, and volumes. In other words, measurement. In this lesson, we will look at measurement with regards to perimeter and area. Where have you heard the word perimeter? Perhaps you have heard the term perimeter fencing, or as they say in the army, make a perimeter. But what do they really mean? In either case, perimeter refers to the total distance along a boundary. And not just any boundary, but a boundary around a closed figure. In mathematics, we define perimeter as the total distance around any plane, shape, or figure. Did you know that in the center of Spanish Town, there is actually a square? How would we find the total distance around it, its perimeter? In practice, we are usually interested in the perimeter around particular places like the stadium. Knowing the total distance around the stadium allowed us to determine the length of fencing needed to build the fence around it.